day that actually will announce, and it will be on the basis of your preparation. So maybe within this week, that whatever you will have, that will be previous few chapters, and the later one that we will take before the exam, that will be on the basis of your final exam preparation. So I think that there will be no problem to you about those quiz exams. Okay. Okay, we discussed about homogeneous coordinate, right? If you can
Yes, sir.
remember, homogeneous coordinate, that actually we have discussed, because we are taking our problem into 3 dimension now, and we are considering all of our transformation function now into 3 into 3 matrix. The z coordinate especially is actually 1 in that homogeneous coordinate, and that will give our formula. That is also you have discussed now in this form now about the translation or the rotation and also in the scaling. Okay, so that we are going to actually start discussing about the composite transformation. Okay, so what actually we also have discussed about this one, maybe, right, that whether the matrix multiplication, they are actually associative or commutative, because the order of that this transformation function, as they are now matrix formation, their order are actually very important. I think we have discussed up to this point, right?
Sir, last class we discussed only composite transformation up to. Yes, sir. This one.
This one I have not discussed yet, because I can remember maybe up to that we have discussed, right? We said like we are going to do this one in this general pivot point rotation, this one. Maybe I just start, but did not discuss in
Yes,
detail,
sir. Yes, sir. Yes, sir.
right? Okay.
Yes, sir.
All right. So just a quick recap up to this point, because these are now relevant for doing the composite transformation. One is actually to understand the homogeneous coordinate. Earlier, we tried to actually check in detail about individual those functions of this translation, rotation, and scaling. Especially in scaling, is always very powerful actually transformation function, and it has some variation. That's actually the issue. It has some variation regarding the scaling factor. The values in the scaling factor, if they are same, they are uniform scaling. Uniform scaling only change in the size. Okay, we have seen that only change in the size, not change in the shape. As this example, the size can be either magnification, or maybe that we can say can be larger, or maybe the size can be smaller when you have the reduction, but no change in the shape that we have actually seen. Now for uniform scaling, this is always you will find that the factors are actually same for the x coordinate and the y coordinate for the scaling. Now whenever we found that a scaling is actually the factors are changed regarding that x coordinate and y coordinate, that means x is of x and s of y, then we find that the shape also actually change, not necessarily only the size, it's the shape also actually change. So that's why it's actually quite powerful that we have seen. In homogeneous coordinate, by default, we consider actually the z coordinate is actually the one value. That means every cases that whatever the two-dimensional point that you are actually plotting in that space for that homogeneous coordinate, the depth of that actually space is always same. Okay, consider that is inside a cube, that actually cube shape we have, and we have seen that easily we can map back, like in 2 dimension to 3 dimension, 3 dimension to 2 dimension, that we can easily actually map that back. So all the points along the each line can be mapped back to the same point in 2 dimension, give this coordinate system name. So that's why it's called the homogeneous coordinate. Homogeneous is actually same type, that word means. In matrix representation for that 3 into 3, the translation, now it becomes that our new point in the translation, the coordinate of that x prime and y prime and 1. Usually what we'll do, we'll try to actually take that two-dimensional value at the end whenever we'll plot in the graph. And the translation factor, now tx and ty, they are actually in the x coordinate position and y coordinate position, indicating that this is the x coordinate position, y coordinate position, z coordinate position. Okay, in the translation, having the dot matrix product with the old point. Okay, old point coordinates. So that if we do that row and column like that, we can actually find out actually x prime should be that x into tx and plus y into ty. Finally, we will see that how actually that equation come out. And the rotation, as you can remember in the two dimension, it was the rotation function that cos theta minus sine theta cos theta. Now we take only the z axis for it, so 0, 0, 1 and 0, 0, 1, and that is also dot product with the old points coordinate value. And in the scaling factor, that matrix was s of x 0, 0, s of y. Now actually we added that 1 for the y z coordinate, and having that dot product with that x, y, and 1, that actually we have seen as we are having dot matrix product, and also when we go for composite transformation with having multiple different transformation at a time. So that's why this is very important to understand that whether this matrix matrices like this one for this one for this one, when they will go for dot matrix, then what should be the order, what should be the sequence one after another. That is actually important to check. And for this reason, that transformation in a single matrix, when actually we had matrix to matrix only, that was not a problem, or matrix to vector, that was not a problem. Okay, now when we go for composite matrix, and we have seen that composite matrix transformation is actually the real life scenario for the object's movement. When you will have something like that, that they also, we have seen that in the program in OpenGL as well, that you are actually sequentially using that functions one after another, so that you can see the object is actually having a rotation, simultaneously it is moving in the other place, one place to another place. So that we will check that what it should be. In composite, the word means actually the mix up. So that transformation. So whenever that concern is coming, that matrix to matrix, that order, that operation on that order is actually have some matter or not. In algebra, whenever we have actually the sequential, that numbers, actually the mathematical operation, we have seen that order is not always that much important, as long as that as it has been defined. So that if you have a different function, then maybe the order is important, but in some cases it is not. Like associativity, they have that associativity, no problem, like a and b, that dot product that actually you are doing, and then actually c. Like if you consider any number as well, like a into b into c, whatever the way you come, the value comes actually same. This is actually associativity. Okay, also it is commutative in that sense. A b b a, that means you change the order, still that actually support, but in matrix it is not. Okay, that we have seen in here in the matrix for associativity, that a b, we did the a b, that dot product first, then actually we done with c, and we get this element in the matrix finally, whereas that b and c we have done first, then we done with a, and we get that element. And we have found that these two elements in the matrix, in these two matrix, the elements are actually same, so that they are associative. Okay, so no problem in the associativity if we actually do before and after have some done this way. But the commutative is, it is actually a matter, so that whenever we have done a dot b and B dot A, we have found that this actually not same. However, in algebra, that the numbers especially, they are actually commutative. You can see here that the elements we get, that row and column like this way. If we get that four elements in that matrix, and the four elements in here, they are actually different. Okay, so we cannot actually change the order. That is actually the important case. Also, with the diagram that we try to check, that order of the operation has to be actually according to the order that we have, like translate and rotate. Here we have done rotate and translation, same value, that is no problem. Like I'm doing translation here for, say, tx is 5 and ty is 5. Here is also, I mean, tx is 5 and ty is 5. Here I'm rotating 90 degree, here I'm rotating 90 degree. You will find that that is actually, that will be changed. The position will not be the same, because when I do first translate, it moves from one place to another place. You can see that no change in the orientation. And then I do rotate, some degree of positive rotation I have done, so that I go in the counterclockwise. Okay, now my position goes in there. Okay, the same degree, same actually factor I applied. The rotation first, you can see that from here, the rotation first, same degree, the positive rotation, I am in here now. And then I apply actually the same translation factor, and then actually you see that where actually I end up. Okay, so it is important that this chain, this order, we cannot change. Okay, if we actually change it, then actually our outcome will be wrong. Now let's come to the general pivot point rotation, the first composite transformation matrix. What actually in happen in here, that pivot point rotation, we said like, uh, the pivot point is a point where actually that your main rotation, that degree of orientation you to count, the angle, that whatever actually that angle you have defined. Now, the first thing for pivot point rotation, it's a general pivot point rotation. Usually, what actually we have seen for any object, it consider its rotation on basis of its origin. Okay, so it's up to its origin. Actually, you do your rotation. Now, at this case, that this object, it's saying that it will rotate on any random point. Okay, that whatever the random point you have in the space, on the basis of that it will have a rotation. So that whenever this object is saying, okay, this object should rotate on any random point. Now, for easy understanding, this problem is saying that, okay, you rotate on that this point. You can see that green color point is actually on that point. This is actually a random point. This object supposed to rotate actually on the basis of that origin point. Now, every rotation or even the scaling happens on the origin, but you are saying that rotate on that point. So if I need to do that one, what actually I have to do, I have to move that pivot point, that is actually the pivot point I'm actually defining, to my origin. Okay, if I move that point to my origin, then in respect of this point where actually my object is, that my entire object is actually have to move in here, so that my pivot point is become to the origin. Okay, then I will apply the certain amount of that degree of rotation, that's actually it says rotation. Then I will actually rotate. Now actually my object was not in here, so that I have to move that object again in there, right? So to do that one, what I first need to do, I first need to do actually my translation for moving that point into that origin. If I move that point into my origin, say like it is yeah, 2 and uh, 3 and 2, the value for that pivot point, how I can actually come back, make it to the origin, what I need to do, can anyone tell?
So 0 0.
0 0 is the origin, but how I can actually,
So by decreasing the value -3 -2.
Inside decreasing in the value means how you can able to decrease. It's very close. Yes,
Sir,
you see
because
that,
it will coming down, sir. Pivot point to origin. Whenever we come
right?
back, then it will be decreased.
Whatever the value of your pivot point you have, you only need to actually subtract that one so that actually you can come to the 0 0, right? You have 3 2, so 3 minus 3 is 0, 2 minus 2 is 0. That is my translation factor, isn't it?
Yes, sir.
Did you get my point?
Yes, sir.
So that actually whenever you apply that translation, and that translation is actually what? Negative translation. What actually you are doing? Minus 3 minus 2, 3 and 2 minus 2. So it is a negative translation, so that it actually come in here. Now that translation factor have to apply to your entire that object, so that your object actually move down in here. Do you get it?
Yes, sir.
Yes. So now I actually move down in here after doing that negative translation. You can see translate, pivot point is moved to the origin. So that translate is actually negative translation that we have. Now we have a theta degree rotation, certain theta degree we have. So on the basis of that point, I'll actually have a rotation. So say like it has a theta degree rotation now. Now this is this object's actual position is not here actually. For doing this operation, we actually apply that translation factor so that object moved in here, right? Now what we need to do, we need to now apply that same translation factor that we have actually applied the first. Now we actually apply that one, and then the object will move in the previous position. Okay, now this is actually the actual after transformation function that actually we wanted to actually apply, right? Do you get it? Now this is called general pivot point rotation. Now this is point in here, this point could be in somewhere anywhere like this. You may say like, okay, on basis of that point you do have 60-degree rotation of your object. So what you need to do, you bring that point down here. Whenever you bring that point down here, this point and this object has a relationship in the space. You, if you change that point, you must also change the position of that object as well, otherwise the relationship actually that destroys, isn't it? So whenever I actually put down in here, the same factor has to be applied for that object to put down. So object comes in here maybe, okay, after applying that one. Then from here with the origin, you actually apply that rotation function. So you will go in somewhere, then actually you return back that translation. So according to the operation, at first I am doing negative translation, then I am doing rotation, and then actually I am doing the positive translation. So I'm actually returning back. This order of that sequence for composite transformation is always from actually right to left. Okay, so whatever we apply, that actually you have to, the matrices that actually you will arrange is actually right to left. So at first actually we are getting the negative translation, as you can see, which is actually minus tx minus ty, because we are coming to the origin. Okay, then we have the rotation matrix, then we have actually the positive translation. That's the same apply for returning it back. Okay,
Sir, is it
now
so that for rotating an object, we have to bring that to the origin, then we'll rotate, and later we'll transfer to the previous position?
exactly
But
that
sir,
actually we
why
have done.
we can do that? Why
Why?
why it's exactly there? Why we need to bring there on the origin?
Because every rotation or scaling function, whatever you do, even for the translation as well, all are counted according to your coordinates. Do you understand? So that rotation you are going to apply, that will be that by default actually they work like this way, that from the origin they do count,
Got it,
right?
sir. Yes, sir.
And the entire thing is actually end of the day we will do in two-way. Okay, two-way means actually this part by part that activity also will do. Also we will apply this formula. You see that we are generating now formula. These three of the operation that we segmented, the three things happens. Now we are actually, you see that going to in one matrix now. Do you understand? So
Yes, sir.
if you just apply your object on that formula, automatically you will get your position. But how actually it has been done? It is actually in breaking down, taking to the origin and actually finally go back. The both of the cases, the result will be same. Just we will go for an example, then it will be more clear. At this moment, you will see that uh, first those right hand side, those two matrices, we have done actually the dot matrix product, and we get actually like that cos theta minus sin theta minus tx cos theta plus ty sin theta cos theta. So if we do like this row and this column, row and this column like this way, if we go for actually all of them, we get actually this one. Okay.
Yes, sir.
Then this two, if we do this two, then again that row and that column, row and that column like this way for getting the all element, we get actually finally this one, that cos theta minus sin theta minus tx cos theta plus ty sin theta plus tx, and here sin theta cos theta minus tx sin theta minus ty cos theta plus ty, and 0 0 1. So now this is actually my composite transformation function for general pivot point rotation, right? Now how we can actually solve it? This is actually the formula we get. Again, to get our new position, this formula has to be applied to the old point so that actually we can get the new point, right? Just for an example, what try to understand what actually it says. You see that so far, if we consider that perform, it says 60-degree rotation of a point, the given point is 25, and about a pivot point 1 2. Okay, so you see that it says my point is given 25 and my pivot point is given 1 2. Now find the p prime. Okay, just this problem, you consider that at the earlier when we were trying to understand about rotation, what actually it says? It says find the transform point p prime caused by rotating of that point, the given point is 5 1, about the origin through an angle of 90 degrees. So it was about the origin defined, right? So your pivot point was actually the origin itself. Now it is saying no, I am not actually going to do about the origin. I want actually to be done in a specific different point, a general. That's actually give you the general that word, the general pivot point rotation. So in the random point in the space, that actually we are counting. Now it's very easy because this is my theta. It should be a positive rotation by default. If unless it says negative rotation or minus value, we can understand this is a positive rotation. The point is given actually x and y, and the pivot point is given actually 1 and 2. Now can anyone tell me what should be the value for tx and ty? You see that this is my pivot point rotation formula, general pivot point rotation. How it has been formed, we have just seen now, right? With this composite of this matrices. Now, can you tell me what should be the value from the problem here? That what should be tx and ty?
1 2.
1 2, right? Because this pivot point we need to bring down into the origin, and to do that one tx, that 1 should be 1 minus 1, 2 should be 2 minus 2, so that we can get 0 0, right? So now this translation factor also should be actually apply this one so that we get this new position. But when you apply the composite transformation matrix formula, then you don't need to actually bother anything. You just put the value, do the calculation, and you get the result. The sine 60 and cos 60, it's sine 60 is root over 3 by 2, right? So 0.8660, that the value you get, and cos 60 is 0.5, that half the value is. Now the cost, so we can actually put the value here. Cos 60, right, is 0.5, sine 60 is 0.8866, tx is actually 1. As you can see, tx is 1, into cos 60, that means half, plus ty is 2 into sine 60, that is actually 0.866, and then tx is actually 1. So we put the same way the value in here, we do the calculation, and xy1 is actually 251, that is actually the value we know. Now we simplify here, we get actually that is 0.5, 0.86 is minus 2.232 after doing the calculation, after multiplication and so on. And here we get actually that 0.86 is zero point 0.5, and here also after the calculation we get 0.134 and 251. Now we do actually the final calculation with this row and column wise, then actually we get the value after doing that addition, subtraction and so on, that minus 1.098. Okay, and that you get actually 4.366 and 1. Now always you should actually consider the round value, and as you know that to get the round value there should be actually minus 1, and this should be actually 4, because this is 0.3. So we get minus 1, 4, 1. So in the two dimension we can actually say like minus 1 and 4. So this point, after having a 60-degree rotation on basis of that point, okay, we get actually minus 1, 4, right, the new point's location. Now we will do that. This is actually, I have applied actually the composite transformation matrix formula. Now I will actually I will not actually use this formula. I will do that actually sequentially, the way actually it has been defined, the process, okay, the order of that operation. So that actually I will do in for the same problem as well. Here actually the problem they have been changed, but we can actually do that in the same problem, maybe in this diagram, because during your exam you will have a question and will be asked, do with using the composite homogeneous matrix formula, and also do it without using composite homogeneous matrix formula. Now also you show on the graph that without using composite homogeneous matrix formula, okay, that will be asked you to do that one. Okay, now we can actually do that for according to the step by step, the two things that actually you can we can do. So let us go for in a graph to do that one, for without using homogeneous transformation matrix formula. Open a graph in here. So if we take the problem that was actually we are going to do that without using composite homogeneous matrix formula. So with formula you have understood that what you need to do whenever you are doing actually with using formula. Is there anyone have any concern about with using formula, that whenever actually first using the formula? Do you have anyone any concern? Yes, Ashik,
Yes, sir. It's okay.
it's okay, right?
Yes, sir.
So you simply actually need to apply the formula, whatever the value you have given on your problem, you just put down in that formula with your point, given point that you need to find out the new point. And after the calculation, actually you will get the value. We can show that on the graph as well, but whenever we are doing the same problem with actually this same problem with your without using homogeneous formula, that time actually we can we can easily find out there is also actually the position of that what is called that without with using formula, that is also actually we have a position here. So we will see that how actually it will be. So this is actually 60 degrees. The symbol doesn't come. Okay, so what we need to do at first, we need to do actually that um, we are doing that this one without using composite. Just do not mix up. So when we are going to do about that without using formula, so that first thing we need to do according to the order. We have seen that the order was actually first doing the negative translation. So in my space, maybe let us start doing the drawing first with the graph as well, will be better. So how many points do we may need for to do some calculation? So better we go for somewhere here. So like this is actually my y-axis, and this is my x-axis that we are going to do. Now let us actually plot those points first, then maybe we are going to check. The point has been given is P25. Okay, so we go and find out that for P25. So 1 2 1 2 3 4 5, or let us better check 2 actually unit for 1, or 2 boxes for the 1. That would be better than. So 2 5 would be 1 2 1 2 3 4 5 1 2 3 4 5 6 7 8 9 10. So this is actually 2 5. We just take that coordinate point in here. So just point out is this is my 2 and 5. We have taken 2 boxes as 1 unit, right? And whatever actually it has been given, the pivot point has been given 1 2. So also we let us point that to 1 2. So this is 1, this is 1, and this is 1 and 2, right? So this is my actually pivot point is pivot point is actually 1 and 2. Okay. Now it is saying according to the actually the problem says, actually if you try to understand what actually problem it said in the graph. So 2.5 will have actually 60-degree rotation on the basis of that point. So somewhere that point you will find in there. Okay, this is actual find out. But for composite transformation matrix, what actually we are doing, we are at first actually changing the position of, or actually we are uh, changing the position for the pivot point first, so that we are actually bringing that pivot point down to the origin, right, for the translation, negative translation factor, so that actually we can say the origin is now actually the pivot point. To become actually now 0 0, right? And that was we were discussing that in the space you see that it has a relationship, this point, this object and this pivot point, right? Now when my pivot point I have moved in here, so automatically that distance is actually changed. Now it is not actually possible, we must need to actually do that, move that object with this translation factor as well, right? to take that pivot point in here, we have to do what in the translation factor is actually negative, right? So that what actually we can find, you can see that at first we need to actually do that, translate that pivot point. Okay, so if we want to translate that pivot point, so automatically that point also will be moved. So the first point that actually we are doing, in the first operation, that we need to translate the pivot point to the origin. So the translation factor is now what actually we get, the t of x, right? That is actually -1, as it was actually what? Sorry, as actually it was actually the pivot point was 1 and 2. Okay, if it is actually the pivot point is 1 and 2, so the translation factor is become actually -1, and t of y should be -2, right?
Yes, sir.
Because we want to come into the origin, so how it will become 0 0, so 1 should be 1 minus 1 and 2 should be 2 minus 2, so that actually it become that -1 and -2. So now object, therefore my object, therefore the point P is my object, which is actually 2 and 5, will be moved in what should be the new position at this moment. Say like that is my P prime is actually that 2 minus 1, right? We are applying that tx and ty, that applying the factor, and 5 minus 2, right?
Yes, sir.
That become actually that 1 and 3. Okay, what actually we have done, as you can see here, that we have actually done that pivot point is moving here, so that same unit of that value will be applied in here to move that object as well, so that it, after doing that, we get actually 1 minus 3. So this is 1, this is 1, 2 and 3, so this is actually the place we get ourselves, right? So we get ourselves is 1, 1, 2 and 3. This is actually my new position now of that object. So this is what we get. P prime is actually now 1 and 3. So that same unit now have been applied. Do you understand now? You see that the same relationship now
Just coming
as
down.
you are having now with this origin with this one, right?
Yes, sir.
Does all of you have understood actually what we have done here? Yes? Anyone have any confusion that what actually we are doing? Now, according to the order, what actually we have done, we done the normal rotation function. You can see that this is not composite whenever we are doing that in the without using formula, we are simply applying the two-dimensional that formulas. Okay, it's not actually necessary to take you in the that three-dimensional matrix. But whenever you are using the formula, with using the formula for that composite, then you take the 3 into 3 that formula. Okay. Now you can see here that rotate about the origin, that actually we need to do it, that rotation about the origin, and then we'll again do the translation back. So the second activity of us will be that now rotate according to the given that degree, that actually 60° we need to do. So now we can say that in 2 should be that we need to apply the rotation function on the point. Which point? T prime, right? Which is actually 1, 3 now. So we are going to apply this one. So what actually we get? We get a new point, right? So like P double prime should be that the rotation factor that actually we have, and with the dot product with actually which one? The P prime, right? So this point now will have a rotation with this point, and then actually we'll get a P double prime of a point. Okay, so if we apply that one, then actually the rotation function and the P prime, we know that this is actually coming out of that the formula after doing this one, that the point of which is actually the P prime that we get, and that 60°. So we get actually that if we do that, then we got 1, that is actually the x, and 3 is actually the y. So that 1 into we get 1 dot that what was the formula? Cos theta, right? X cos theta minus y sine theta. So that this is x, and cos theta is actually at cos 60°, right? And minus y is actually that 3 dot sine 60°. This is for the x coordinate, right? That we get. Now for y coordinate, we get actually the x sine theta plus y cos theta, right? So 1 into that sine 60, and plus y is actually 3 into cos 60. Okay. Now if we actually put the value, we have seen that 1 is 1 into cos 60 is 1 into, what was the value we have seen? 0.866, right? Or no, cos 60 is actually 5. 0.5, just take 0.5. Okay, this is 1 into 0.5, should be used the cross mark, actually it is the better one, minus 3 into that value is actually 0.866 maybe, right? 0.866. Okay, and in here that this is for the x coordinate, and for y coordinate we get actually 1 into sine 60 is actually that was right.
0.887.
Yes, that is actually the two-dimensional as we are doing. 1.8086 is 0.866, and plus that 3 into 0.5. Okay, so that if we just let us extend that one. So 1.5 is actually 1 into 0.5 is actually 0.5, right? Minus and this one is actually 3 into 0.866. So this would be 3 into
2.59, sir.
0.866. It's 2.598, right? Okay, 2.598, and here in the y coordinate we have 1.86 is actually 0.866 plus that is
1.5.
actually, sorry, that is what, 1.5, right?
Yes, sir.
Plus 1.5. Okay, let us do the final values to put uh, 0.5 minus 2.5, that is actually minus 0.5, we get 2.098, right?
09. Yes, sir.
We get actually 2.098, and for x coordinate, and in y coordinate we get
It
2.366.
will be minus 2.098 because 0.5 minus.
minus,
Negative, sir.
that
Yes,
is
sir.
minus, yes, that's right. And here actually we get what was that,
2.366.
2.366, right?
Yes, sir.
Okay, do not make the mistake, then actually all will be gone. Okay, so if we take the round value for it, that is actually we get minus 2,
Plus 2.
right?
Yes, sir.
And plus 2, and get actually the plus 2. Now this is actually, we get a point, we get actually our object now in doing that rotation of 60 degree of this point in to the origin, then we get minus 2 and plus 2. So let us plot that point. So minus 2 and plus 2 is 1 and 2. For minus 2 and plus 2, 1 and 2. So this is actually the point we get ourselves, is this is P double prime is minus 2 and plus 2. Now this is not actually our main point, because you see that we moved our main location of that object was in here, and we have moved that one for some reason, so that actually we get it actually now in here at this moment. So what actually we need to do, definitely I need to move my object back according to the same translation factor, so then actually I will get my actual position. Okay, so what I need to do, that point I have to apply my this translation factor back. Okay, that means positive translation I need to do at this moment. So if we do the positive translation at this moment, so we need to translate back of of the we need to translate back of that point for p prime. So we need to translate back the point or the object, that p plus with the same translation factor, which is actually 1 and 2. Right now we are doing actually the positive translation. Okay, as we are actually translating back, as you can see that earlier whenever we have bring it down, so that's why we have applied the negative one. Now we are actually putting that back. So whatever the our space we have, all we are actually putting that back, especially that object that actually we have got with the same factor. So that's why it is a positive translation. So my translation factor is actually now Tx is actually what should be? Tx is 1 and Ty is
2.
2, right? Tx is 1 and Ty is 2, should be the positive one. So that's why. So we get that P triple prime, that is maybe our desired point, it should be whatever we have got in P prime, that was actually -2
+2.
and +2. So we get in here that -2 plus 1, right,
Yes, sir.
for x coordinate, and y coordinate is 2 plus that 2.
2.
Okay, so we get what actually?
-1 4.
That -1 and 4, right? That actually we get, this is actually our main point that actually we are looking for. Okay, so we get actually the -1, the value is actually -1 and 4. -1 and 1, 2, 3, and 4. This is actually my actual point after the that rotation, pivot point rotation that we do. So that P triple prime is actually that is actually for -1
4.
and 4 that we actually get, right? So for, you see that whatever actually we had in the calculation with using formula, you see that with using formula the value also you have got was actually -1 and 4, right?
Yes, sir.
So with using and without using, you must actually have to be the same. So if you have a question, actually this question is also, student automatically come to know that whether they have done the calculation and their all the activity was right or wrong. So that -114, yes, after doing that without using formula, in here that look without using formula that we have done, we get actually the same value -1 and 4. That means our activity was right. Now what actually again we have done in here, we also actually moved that one, right? Moved that one, this point from the same translation factor from here to there. Now actually if we just try to show that what actually we have done in these cases, you can see here that actually what the question says have a 60-degree rotation from this point to this point. Now if you add, you can see that what actually happens in here. So for we take the line again, so like what actually happened, we can find out that. So you can see here that this movement, this is actually the 60-degree rotation happens, and this is actually 60-degree rotation happens. Okay, so if we just try to identify that what actually happens in here. Yes, can you see the full screen or? So that I had my object, the question says now that do the rotation, 60-degree rotation on this point, and then you find the location of the new point. So in composite transformation actually happens that the pivot point there when the transfer in here, so your actually entire object in here that also has been changed, and then actually you have done the rotation with that point. Now the point that you have got or the location of that your object has been changed because of that translation that you have done earlier, so that you need to actually change that one or return that one in the previous place, so that actually you can get that object. Did you understand now what actually we have done?
Yes, sir. Got it.
Got it?
Yes,
Okay,
sir.
that's fine. It is, time is over and my another class is already started. Quickly come to the video. Okay, let us finish with this attendance. So one of the problem you are going to have this one. Okay, so in the slide you will find another one has been done. Look, this one has been done for uh, a different values. So you can do this one with formula and without formula and plot on the graph. You have say like 10 marks. So you will have maybe three marks for the calculation, but 4 marks for the graph work. Okay. As you can see, that graph work is actually main important part. Okay, we have Alif Laila. Do you have Alif Laila Jannat?